Somebody saved our seats up there.
Okay.
Somebody said it was a pretty good seats.
Anybody have something they want to bring up in relation to the first two programs? Okay. All right. So I think the last thing we did was we read through the Leibniz-Clark debate, particularly on the clockwinder question. So I guess we can continue reading, and I'll sort of interrupt. Let's see. All right, so why don't somebody read the first, you got the founding work, respecting the two paradoxes.
Where's that?
Where are you?
Oh, I
Page
see.
39.
Well, since I know where you're starting, I guess I can start.
Respecting the two paradoxes.
Right, it's on the left-hand column
Yeah.
about
I see.
2/3 of the way down.
I
Okay,
see it.
so this is from what document?
Oh, this is the same thing, the LaRouche's discovery.
Okay, all right, good. So he says, respecting the two paradoxes originally posed to me by my theses against statistical information theory, the relevant problems in mathematics are a tangle of two respectively distinct but interlocked sets of problems. Once this tangle is understood from an historical vantage point, my solution to the cited paradoxes is more readily intelligible. The founding work of modern science is Nicholas of Cusa's De Docta Ignorantia, in which the pivotal mathematical discovery referenced is Nicholas's revolutionary treatment of Archimedes' theorems on quadrature of the circle. Nicolaus's new solution for these theorems is also a form of demonstration of the general solution for the ontological paradox depicted within Plato's Parmenides dialogue. Nicholas's discovery is, in fact, an illustration of Plato's principle of human knowledge, hypothesizing the higher hypothesis.
Okay, just up there. Anybody want to say something about what they think was the core of Cusa's argument in the quadrature, demonstrating you cannot square the circle?
Well, one aspect is, it is paradoxical because it seems that the closer that you're getting, the farther away that you're getting. I mean, that's one aspect of it. I mean, people who try to approximate it by adding sides to a polygon or something like that.
Okay.
Could it also be about the idea of perfection? That, you know, you have a circle,
Yeah.
and there's only one way really that you can create a circle. You know, by rotation. And, polygons are completely different. They're imperfect.
Okay.
And, I just guess that
Okay.
Cusa's dealing with the circle from the standpoint of God versus man.
Well, you said something about circular
Right,
action. He
circular.
starts with circular action.
Yes, yes, a folding.
Okay.
And that you can't do geometry that way. I mean, yeah, no, you could make a tetrahedron, and you could by folding, but not a perfect fold, which is what a circle is. You can derive these 5 platonic solids from the circle.
But you can't derive the circle from that.
Well, how does he attack Archimedes? What does he show as the flaw in the idea? What is there about the circle that proves you can't? What is there about the geometry of the circle what makes it incompatible, incommensurable with any figure made of straight lines?
No
And it
angles.
has no straight lines and no sides.
It's curved.
Yeah.
There's no angle.
And more specifically, in what is the curve enclosed that's incompatible with
The greatest area at the smallest.
Yeah, the maximum, minimum.
Why don't we put up the, let's see which one.
Have a seat.
Put up the second,
Yeah, this seat is free, and this one can also be free. It could be free, yes. All right. Could you flip the screen the other way? The other way, the other way.
let's see. Second angle. Okay, why don't we see what he's saying.
Ernie, which one do you want?
Why don't you start reading where it says on the first page, where it says, Cusanus begins his work with a proposition. That's the second column.
It was, in which that was the American Almanac that you
Yeah,
had up
the
there.
other-
It's gotta be
Yeah.
put
The
up.
third paragraph,
Yeah,
or really
tell
the
me.
second full paragraph in the second column.
There it is.
So you're gonna need to zoom in.
Yeah.
And there it is where he says 1. Cusanus begins his work with the proposition based upon the assumption of the validity of Archimedes' proof. The proposition is as follows. If to a given perimeter of a triangle, an equal circular perimeter can be given, then the radius of this circle exceeds by 1/5 of its total that line, which is drawn from the center of the triangle to the point quartering the side from the corner.
Wow. That is something from Archimedes. Huh.
This is, yeah. Go ahead,
Okay,
Kenny.
keep going.
In the course of the work, he will explain this proposition and derive from it an approximate value for pi. However, through this proposition, he will simultaneously show why the value obtained is only approximate and not precise. Before elaborating on this proposition, however, Cusanus proceeds to challenge the axiomatic assumptions underlying Archimedes' work. As Cusanus stresses, Archimedes' proposition assumes that where one can give a larger and a smaller, one can also give an equal. But as Cusanus continues, there are those who deny the possibility of the quadrature of the circle, and they assert that, in mathematics, the conclusion does not hold that where one can give a larger and a smaller, there one can also give an equal. Then Cusanus goes to the crux of the matter. He writes, there can namely be given an incidental angle that is greater than a rectilinear, and another incidental angle smaller than the rectilinear, and nevertheless never one equal to the rectilinear. Therefore, with incommensurable magnitudes, this conclusion does not hold.
Okay, let's go to the second page. You may have to shrink it down a little. Okay. All right, the people see the representation of the two incidental angles and the one rectilinear angle in figure 8.
See figure 8 in the middle column?
Yeah, it's the first one in the middle
You
column.
want to make that big.
Okay. So he says, the caption says, the incidental angle B is greater than the rectilinear angle C, and the incidental angle A is smaller than the rectilinear angle C. Yet there is never an incidental angle equal to C.
That doesn't make any sense. You're gonna have to go through that a little.
Yeah, okay.
Show
Okay.
what you're
Okay.
reading.
This is an incidental angle. And
People might
this-
not know what an incidental angle is.
No, I-
It's an angle, one side of which is straight and the other is curved.
So
Okay.
you're talking about this angle here
I think he's talking about the whole
whole
angle.
angle.
That-
No,
The
he's talking about that
diameter to the
angle
edge.
right there. That's angle B. Yeah, what Art is referring
No,
to.
No.
angle B goes all the way to the circumference
Yeah.
of the circle.
Otherwise, it doesn't have a side that's curved.
Right.
It's all right, we'll figure
So
it out.
angle B is the large angle from the diameter to the circumference.
Right.
Correct.
Which is greater than C, which is.
Oh, I see, okay.
Right.
The two straight sides. The incidental
Aren't there two
angle
B's
A,
up there?
where's,
Or
Doesn't
might
look
look
A
like
is
not
that
straight.
little one from that line to the curve.
okay.
Is my eyesight bad? Are there two B's on there?
blow it up.
No,
No,
the A
it's a
looks
little
like
A.
a B.
Yeah.
This is actually A, yeah. That's A, yeah.
That's better.
Yes.
Incidental angle A is smaller than the rectilinear angle C, yet there is never an incidental angle equal to C.
Because an incidental can't be equal to a rectilinear.
Yes.
I think that's really ingenious. It's so simple.
How does that prove anything?
Because you can never equate, what if you wanted to equate what you call the segment of a circle,
Hey, what's that letter?
or, you know, anywhere up to half, say the half the circle, you could never equate it
It's too
to,
far away.
you could never equate it to a figure with straight line sides, because the angles are, these angles can never be commensurable. You can never have an angle which is equal to you can never produce a rectilinear angle which is equal to the incidental angle of such a figure with a curved side. That's why.
The only way that it would be is if AC were the tangent at A. Then it wouldn't be a segment.
Well, I was looking at that and saying, well, it doesn't look to me like, all right, the incidental angle B is greater than the rectilinear angle C, and A is smaller than C. But it seems like the incidental angle B sort of changes
Yeah,
depending on where you
exactly.
take it.
Exactly, it's
You know,
90 degrees at A.
Right, it's 90 degrees at, it's 90 degrees at A and it's 45
But
degrees.
it's never
Yeah,
actually
but it's
90
nev-
degrees because
Exactly.
because you're going to keep on, you can approximate it as 90 and say it's close enough, but if you simply zoom in, then you're going to find that it's
Yeah.
actually curved where you were counting it as straight, and then you're going to zoom in further and it's actually curved where you were counting it as straight
Right.
ad infinitum. And so you could never count it as being actually 90 degrees.
So it really is incommensurable. You can't measure it against these other.
But I guess it has to be
Rectilinear angles.
greater than C, no matter
Yeah.
where you measure it.
What, A?
B.
Oh, B.
B has
Yeah.
to be greater than C,
Right.
regardless of that question. It's
Yeah.
always gonna
No.
be larger.
Oh, well, that's a really funny thing, isn't it? Because if you took, what if B were on the other side of,
Oh, it's, yeah,
yeah, what if you took B way over there?
yeah, that's true.
Then, I mean, if your angle B, if your line went past the direct, you know,
Point C.
if your line were to the right of that, so that you were going across the middle of the circle again,
Right.
then the angle, I mean, how do you measure an
How do you
incidental
measure a
angle?
curved angle?
Yeah.
That's the problem.
You don't just measure it from like the tangent to the curve
The tangent to the curve.
at that point of intersection.
Well, it depends which angle you're going to measure. If that's an angle between two straight lines, or is it an angle between the tangent and the curve? He also
Well, like, for
discusses that
example,
next.
You could run a tangent line to the circle at A.
All right.
Going straight up?
Yeah.
Right.
And then just say that therefore angle D is 90 degrees.
Well,
But that's actually an angle between your tangent and the and it, and that's not the angle between the curved line and the diameter. That's an approximation of it, but that's not it.
actually, anybody else? Shall we read on and see?
What
this?
exactly does that, assuming that that is the case,
Yeah.
I'm not quite sure how that relates to the question of the quadrature of the
Oh,
circle.
Because
okay.
if you take, you can't find any area, any figure with made of straight lines, like a square, that could possibly be equal to a figure which has such a curve in it. That's why, because they're not, the angles are not commensurable.
So you can never have an area that's equal,
Yeah.
a
Well,
rectilinear to a
I mean,
curved
obviously,
area.
there could be figures that had the same area. You might not be able to prove it or compare them.
That's right. That stops.
Yeah.
Stop right there.
Yeah,
You can't
exactly.
compare them. They're different species. That's the whole idea.
Right.
Yeah.
So if you can't compare them, then you can't measure them, and they can't be equal.
Exactly.
You don't know
You
that.
can't know it.
Right.
Yeah.
It might be unknowable.
That's yeah. That's right.
What if it could be known, but not using mathematics? I.e., if you got the area, and the original question from ancient Greece is, give me an area of a square box that has the same area as the circle. What if the area was the original question, and the final, whatever you're doing, right, gives you an area that's contained by a square box,
Okay.
and an area of the original circle, and not using mathematics, algebra, or computer, you could prove that the areas are the same. And the question is, can you get an area contained by a square box to equal your original area, not circumference, if it's straight or curved, area of the original circle to be in a new container, square box? Is there a proof? And can you prove it? Can you test it?
Then you prove that the things are equal.
That the area, not the side, is a
Okay.
curve or the area. And that was the original question from ancient Greece.
The answer. Well, this is what Cusa answered. Finally, the Greeks could not answer the question. It was Cusa who first answered it.
Wrong, they did answer it.
Well. I think this is an adequate demonstration that you can't. If you can refute this, fine.
Yes,
But you'd
that
have to
would be
refute
another
him in
class.
his terms.
That would be another class.
Okay, that's fine.
Do you have another one of those that you're
Let's
reading?
carry on and see. It
I think
says-
it might be on that table right in front of
So
you.
see figure 8. Go back to, I guess, the first. I'm sorry, Dave. First page.
Back to the first page.
Yeah. Continue reading, Daniel's reading. Thus, it says, thus it says, what Cusanus raises.
What Cusanus raises is an issue which has divided the scientific community historically. What Cusanus is pointing to is the existence of a type of angle other than a rectilinear angle. The incidental angle of a segment, that is, the angle inside a circle between the circumference and the line which cuts it off. This is referred to in Euclid in only one location, Book 3, Proposition 16, as the angle of the semicircle. The other angle which Cusanus will refer to on the quadrature of the circle is the contingent
Or canicular angle.
or canicular
And
angle.
it says, see figure 9, so we should go to page 2 again. You can't see the top's a little hard to read with my handwriting, so. Okay, so he's saying on the quadrature circle, the other angle, which Cusanus will refer to on the quadrature of the circle, is a contingent or cornicular angle. This is the angle between the circumference of a circle and the tangent. It's referred to in the same location in Euclid as the remaining angle. Let's see, that's, so.
Let me see figure 9.
Figure 9.
You can go to figure 9 for a moment,
I think that's
so
what
people
it
see
is.
it, 'cause
Yeah, exactly.
So it's made up of
Oh, oh,
tangents of the
oh,
circle.
wait a minute, you can, yeah, okay, that's
The
fine.
remaining angle, the
There it is,
cornicular
see?
angle,
Vernacular.
Figure 9.
horn-like angle.
Okay. So, I guess you could go back to the top, people can keep that in mind. go to the
Hold on one
top,
second.
and you could continue.
How do you measure an angle like that? It's
Yeah.
changing
Yeah.
all the
Yeah.
time. That's crazy. I mean-
AD and the
It's the same
semicircle
problem.
AC.
Yeah.
Okay.
I mean, it
We know
seems,
that the two angles add up to 90 degrees.
Yeah, right.
We don't know where the dividing line is.
Well, how do we have 90 degrees?
You need to go to the top where where it continues, Will Wirtz continues his presentation. Euclid's book 3, you gotta make it a little smaller
Where the
so the whole
second
thing
column, where it
is
says two.
visible. Euclid's book 3.
There,
Euclid's
yeah.
Book 3, Proposition 16 reads as follows. The straight line drawn at right angles to the diameter of a circle from its extremity will fall outside the circle and into the space between the straight line and the circumference. Another straight line cannot be interposed. Further, the angle of the semicircle is greater and the remaining angle less than any acute rectilinear angle. According to this proposition, a straight line touches a circle at one point only. Any other straight line which one attempted to interpose between the tangent and the circumference would necessarily cut the circumference in 2 points and thus fall within it. You can go down?
Oh, let's see, we're gonna stop there. You wanna go back to the
Figure 10.
Figure 10, and give people another look at that.
Yeah.
That's figure 9. Here we go. Yep.
The straight line EA is tangent to the circle and at right angles with the diameter AB. No straight line FA can be interposed into the space between the straight line EA at the circumference. Such a line FA will necessarily cut the circle in 2 locations, creating an incidental angle rather than a contingent one.
Again, the contingent angle is the angle which is between the EA and the curve of the surface. AB.
Otherwise known as
Right.
cornicular?
No.
Cornicular or contingent, either one.
Yeah.
Oh, I see, I'm sorry.
The same,
Excuse
or
me.
horn-like
Sorry.
also, horn-like. Okay.
Contingent.
Core line is the outside.
Back up
Right,
there.
Yeah.
So this thing, you're gonna see, this thing has a long history. It isn't though he suddenly came in, you know, from out of nowhere. This has been a hotly debated subject in medieval times. So that's the, you wanna continue if you wish?
Sure.
You gotta go back to page, you gotta shrink this so he can
That's
see.
fine, just go, scroll up.
Yeah.
There we go.
If one wished.
If one wished to argue that the circle can be squared, one would have to insist that the incidental angle is not a true angle, and that the contingent angle does not exist at all. The battle over this issue is fascinating because it goes to the heart of the battle between Platonic science and Aristotelian anti-science. One of the most critical comments on Euclid's Book 3, Proposition 16, was made by Johannes Campanus, who edited Euclid's Elements in the 13th century.
1250.
He inferred from Book 3, Proposition 16, that there was a flaw in the principle that the transition from the less to the greater, or vice versa, takes place through all intermediate quantities, and therefore through the equal. If a diameter of a circle, he says, be moved about its extremity until it takes the position of the tangent to that circle, then, as long as it cuts the circle, it makes an acute angle less than the angle of a semicircle.
Do people get that part?
No.
Okay,
If
wanna
the
go back
diameter-
to the figure showing the, figure 10?
Can you read that while we're looking at it?
Is that
What you
possible?
said?
Okay. Yeah, if a diameter be moved about, that was this.
You wanna read the
Ascending
sentence again?
sentence.
Well, let's do
Yeah.
it.
Okay. If a diameter of a circle, Campanus says, be moved about its extremity until it takes the position of the tangent to that circle, then as long as it cuts the circle, it makes an acute angle less than the quote angle of the semicircle.
That's like F.
Now, the
Yeah.
angle of the semicircle must be the incidental angle.
It sounds like, yeah, I think that you're right, yeah.
In other words, he's saying if you take the diameter BA and rotate it down like
Around
where F
A.
is,
Yeah.
Yeah. Right.
That
People
AF
follow that? Make sure you
And what's
follow,
he
you're
saying?
clear on
Yeah.
that.
Keep going,
This is
and
a
AF
core of the
what?
argument.
Keep going.
Oh, okay.
Just, if the diameter, just do that
No,
again.
we can see that, I just,
Yeah.
what's his conclusion on
We can see what?
Okay.
it? What he's talking about,
Diameter
moving
being
the
brought down
diameter.
towards EA, rotate
Yeah,
it towards BA.
if you rotate BA
Right.
down,
Can you start over and just read what you read again?
if the diameter,
You're saying you would rotate the diameter down to
just if
AF?
you can start reading at that point
Okay,
again, that would be
continue,
great.
okay. If a diameter of a circle, he says, be moved about its extremity until it takes the position of the tangent to that circle, then as long as it cuts the circle, like here, okay,
Well,
Wait a
it
minute.
makes an
how can it be
acute
a
angle,
tangent and cut the circle?
less than the angle of the semicircle.
Yeah, I
Okay,
think
by the angle of the semicircle, I'm not, it's certainly less than
as long as-
EAB, and I think it's also less than the curved angle, the incidental angle too, of the semicircle. In other words, this angle here is less than both this angle here, this 90 degree, but it's also less than the incidental angle, which is the most important thing, the line angle between this line and the diameter.
yeah, in
I
other
couldn't
words,
see- I couldn't
just
see.
ask,
Can you-
how can a tangent cut the circle?
Well, it's not really a tangent yet.
It's not a tangent yet, he's
It's
saying
gonna
on the
be.
way there, okay.
It's gonna be.
Okay.
but
Okay.
I think one paradox is that as long as it's cutting the circle,
Yeah.
it goes around, it's less than the incident
Right.
angle, but as soon as it becomes the tangent, then it's bigger than the incident
Right.
angle.
Yeah, that's what Campanus was saying.
It's like
It'd be bigger then.
instantaneous transformation from
Yeah.
less to greater.
It's not gonna be greater.
It's gonna be greater than the incident angle when
Yeah.
it becomes
No.
a tangent.
No, because the incidental angle will be the tangent at that point.
No, but
No,
it's not. Not in
It's
truth.
not.
You can only
It's a
approximate it as
Well,
such,
then you could say it's undefined at that point.
It's not incidental.
and therefore unequal. It's incommensurate.
Is the incidental angle
You wanna know what we
always
mean by it?
the one between the circumference and the diameter?
The incidental angle is this, it's this angle, it's between the diameter and the semicircle.
So it's always diameter and
It has
semicircle.
a line and a curve together. It's an
Right.
incidental angle, well, it's a line and a curve.
But can it change its magnitude, or is it always
Oh,
diameter?
yeah, they're different sizes, they come in different sizes. Remember, you
that's
had two of
also
them
an
over there, that other
incidental
figure 8, you have two incidental angles.
Right.
Okay.
It's not necessarily
But I
what.
mean,
It's not
like,
necessarily the diameter,
Is,
Yeah.
so is F,
FAE or
can you go
whatever
back
it
to
is.
10? Is the angle between from F to A and then that little sliver of the circumference?
F
that
to A to B,
incidental
F
angle?
to A to B is always less than, as long as
So
it cuts
F-
the circle.
From F to A and then up along the circumference.
Yeah, that angle is bigger.
That's an incidental.
Yeah, that's incidental. It's always bigger, as long as this line cuts the circle, it's always bigger.
What's always bigger? Bigger than what?
But the point is, if you go from cutting the circle to being a tangent, all of a sudden you're bigger. Because the incidental angle is included within that.
Still not bigger.
Is that okay? Is that clear? No, I'll repeat.
What you're referring to.
Oh, okay, I mean, what I'm saying is, here you're comparing
Can you
this
say the
line-
letters, cause I can't see it when you're up there.
Oh,
Go to the other side, stand on the
Bigger
other
than the
side.
angle between
This-
F
okay,
and
that's good. You got-
Thank you.
If you're moving
Okay, you
the
got
diameter
this
down,
angle
like-
here between this curve
Right.
and the diameter.
Okay,
Then you have the angle between this line and the diameter.
right.
As long as this line cuts the circle, the curve, the incidental angle here is bigger. It has to be bigger. Then what happens when you stop cutting the circle, with this line, because it's now a tangent, all of a sudden it's bigger, because this angle includes this angle. The curved angle is included.
What about at A?
No.
At A, does it include it?
Well, yeah, I'm saying.
Wouldn't you say they're identical at A or no?
Yeah.
I'm sorry.
Would you say that the incidental angle at A is identical as EAB at the point A or no?
No, it's less. It's included. It's within. It's less than, like the whole is greater than the part. I mean, this angle is greater than this angle.
The only place where it would be equal would be at the point A,
That's what
and
I
that's
was
not,
asking.
and that's not an angle,
'Cause
that's
the
a
whole
point, that's not a line.
The whole point he makes is you cannot interpose another line. So you can't have, you know, an extra angle more than the incidental angle. You may say it's undefined, but I would not say that the tangent becomes greater than the incidental. You can't say that. That's right.
Well,
There's no
so
extra
if
angle there.
if a point is not infinitely small, see, you can see how much this really does come from the way we consider things. And Leibniz has a lot on this, because unless the point has 0 dimension, if it has any dimensionality at all, then indeed it still has some curvature. Because otherwise the circle wouldn't exist, it would just go off with the tangent. Imagine if those two lines are equal at A, and then the same line goes off, then you'd never get a circle. There's got to be some.
The same line goes off.
If you take the tangent and it's equal to A, BA's been rotated all the way down.
Right.
Now they're exactly the same. So that at point A they're exactly the same. Now, what happens if you extend those lines? They don't go in the same direction.
Right.
Two lines that are
What lines are you talking about?
the tangent.
The circumference and the tangent.
If
circumference
this
of the
line,
curve. The tangent.
if this line
if they're the
becomes
same, then
equal
you're so circle
to
is
EA, it becomes a tangent.
Right,
So EA and BA are the same.
right.
Now, but the problem is when you take that, go from that point and extend those two lines. They're equal, but they're two lines. We just rotated one down to be
Yeah.
on top of the other.
Yeah.
And now you extend them out, they don't go in the same direction.
As soon as it's
You
any
lose the
extension.
circle.
Yes.
It's a
Because-
point. It's an intersection of
No, but
lines.
it's an angle.
But it's an angle.
Yeah.
This is what.
Because all I'm saying is you can't go back to the curvature from the tangent. That's the problem.
You can't.
It's irreversible.
You can't say that they're equal, because then you've destroyed
And
the
if they're
circle.
not, if they're irreversible, then they're not necessarily equal. Because now, you see, the whole idea of a point is a very interesting problem.
Yeah.
Because two lines don't intersect at 0. There's a dimensionality to the intersection. And what Leibniz and what Kuza, part of the point they're making, which is that even in the infinitely small, they're not the same. They're not a line and a curve are not the same thing, no matter how far down you take them. And these are just some of the paradoxes that you generate. Because if those two lines are exactly the same, and A is a point which has 0 magnitude, then if you go try to reverse the process, you can't reverse it.
Because it has 0 magnitude.
Well, it has 0 magnitude, and also they're supposedly equal. So now if they go, it's the same thing as as in fact the description of an orbit, right? It has a tangential direction, which always shoots it off into space. But gravity, at every point, bends it takes the tangent and makes it not tangent anymore. And what, in fact, Einstein says is, no, that's not what's going on. The curvature is embedded in the space-time. So it goes to the same modern-day problem, so to speak. And I think it's interesting because it has something to do with this question of reversibility and irreversibility. But it also has to do with this question of a point. What is a point really? Because if you start with the definition of point and line, you never get to a circle.
Yeah.
It's just arbitrarily introduced.
It's a term that Lynn uses later in the article. It's called the ontological infinitesimal. He's saying that the infinitesimal has a causal quality. And in other words, the infinitesimal retains its species nature no matter how small it gets. It never becomes something else, you know, like a little straight line. It's also like a monad, you know. When Lynn sort of takes that, Lynn, you'll see later, Lynn develops the idea of the monad, and he goes beyond, I think, Leibniz in the way he describes what he includes under the idea of the monad. So I think that's very, very fascinating. So let's. Okay, so what did we say? Companions could only observe an explanation of the paradox that these are not the angles not angles in the same sense. So let's see where we go from there. This is page 2. Let's see, page 3. Okay, third column, page 3. You want to keep reading?
Sure.
Okay.
We're not reading this, are
No. Third column, which,
Page 3. For the curve up there.
Okay.
Far, far right.
Can you zoom in one more, please? For the curved and the straight are not things of the same kind without qualification. There is every reason to believe that Cusanus had access to Campanus's edition of Euclid. Moreover, this is the same issue that Cusanus refers to in the passage in Book 3, Chapter 1 of On Learned Ignorance, cited at the beginning of this article. Cusanus refers to this logical paradox as a certain singularity. In 1557, the French geometer Pelletier
Sounds good.
argued that the angle of contact was not an angle at all. He claimed that the contact of a straight line with a circle is not a quantity, and that angles contained by a diameter and a circumference are all right angles and equal to the rectilinear right angles. For Pelletier, there was no difficulty with Euclid's Book 10, Proposition 1, because all angles of contact are not angles, not quantities, and therefore nothings. Vieta, 1540 to 1603, agreed with Pelletier that the angle of contact is no angle. His pseudo-proof was that the circle may be regarded as a plane figure with an infinite number of sides and angles.
Oh.
But a straight line touching a straight, but a straight, what is that? Yeah, but a straight line touching a straight line, however short it may be, will coincide with the straight line and will not make an angle.
I don't get that.
Yeah, I don't understand that either.
It seems like that would make an angle, if it's a
That's-
straight line, giving a
If
straight
each
line.
little angle of the polygon is measured against the straight line, if it's that close, it's gonna be a straight line.
Well, that's just what we were talking about, what Roger brought up. I think
Mhm.
that's the same idea. The
Okay,
cornicular
yeah.
angle is
Yeah.
really two lines, straight lines coming
Right.
together.
Here it says, in other words, if the circle is a straight line in the infinitely small, then there is no angle at the point of contact with the tangent.
Right.
Not surprisingly, this was also the view of Galileo Galilei. This issue is in no way an esoteric academic issue. It is one of the most profound issues confronting man. The cornicular angle is either equal to null, as the Aristotelians maintain, or it is virtually null, but nonetheless exists, and in fact the circle, which its existence reflects, is ontologically superior to the polygon which is derived from it. If the former is true, then the same argument can be made, and in fact has been made, that neither God nor the human soul exists. If the circle is no more than a polygon with an infinite number of sides, then God is equal to his creation, which is the basis of pantheism, and the soul is not immortal, but rather dies with the body.
What do people think of that statement? Is that clear, or is it anything murky about it?
Well, I'm still thinking about it.
Anybody wonder?
Kind of not, I don't quite get the metaphor on there, I mean, it's.
Okay, well, we should discuss it. Let's discuss it. He's saying repeat, maybe you wanna repeat it?
Yeah.
This
This
issue.
issue is in no way an esoteric academic issue. It is one of the most profound issues confronting man. The cornicular angle is either equal to null, as the Aristotelians maintain, or it is virtually null, but nonetheless exists. And in fact, the circle, which its existence reflects, is ontologically superior to the polygon which is derived from it. If the former is true, then the same argument can be made, and in fact has been made, that neither God nor the human soul exists. If the circle is no more than a polygon with an infinite number of sides, then God is equal to his creation, which is the basis of pantheism, and the soul is not immortal, but rather dies with the body.
Well, we were talking, Ernie and I, about this, that Kuza's argument on the quadrature of the circle in the learned ignorance is part of his whole overall argument for the existence of God. That is, that you have a higher species which cannot be measured. In other words, that you cannot know anything perfectly. You cannot know God perfectly. Right? And that, this is, I think, what he's getting at. But
Yeah.
that's the Campanus is the edition that was used by Pacioli and Kepler. They said so, and it was published in 1250, and it was heavily annotated and copying a lot of text from the Arabic into Euclid's book. So essentially, this was stuff retrieved from the Arab Renaissance, putting the real science back into what had been taken out by Euclid, and there was a big fight in Kepler's time, because Pacioli was, before he died, was trying to publish a whole new edition of Euclid, incorporating Campanus's notes, which had all kinds of physics in it and things like that. So I assume Kuza used the same one, same text. Because Pacioli says so, it's a whole argument. And Kuza also, Kepler also.
I mean, this does seem, I guess we talked about this before in Kuza, this question of form, because you can have in your mind the idea of a circle,
Yeah.
but any circle that we make or construct will have minuscule imperfections. That is, no two circles that we construct, no matter how hard we try, will be identical. But yet you can have an idea of a circle which is actually an eternal conception. And I mean, it is because everything of the, I keep thinking of the Brahms first serious song. Everything here is ephemeral. I mean, all the things that people typically think of as real, which are the things that you see and touch and smell and whatever, are all things that don't last. But the things that actually do last are those which exist in a different domain. I mean, that are eternal.
They exist only in the mind,
Yeah.
or in God.
So what do you think, Margaret? How does
Yeah,
that,
I'm beginning to understand, because you equate the circle with the perfect God, the immortal soul. I'm not quite sure.
This is not simple, okay? There's a lot more. I mean, as we go along, we'll get First of all, Lynn wrote a paper, it's called On the Subject of God, and he's actually, Chuck Stevens sent him something written by Peter Dawkins, who's a professional British atheist.
Richard Dawkins.
Richard Dawkins, I'm sorry, and Lynn responded to it. And Lynn said, Lynn asked the question, what kind of knowledge must human beings have to answer the question about the existence of God? He didn't say, what do we need to have to prove the existence of God? What kind of knowledge do we need to have? And so then he develops his theory of knowledge, which includes, very much includes Plato. We'll get to those ideas, as we.
Who is it that said that, Ernie? Who was it that asked, what does man need to know?
Lynn.
Oh, Lynn.
Rhetorically said, what is the kind of knowledge we would require to be able to answer the question, or deal with the question?
Something like he said, yeah, if God exists, how would you know it? Or something
Yeah.
like that.
Something like, yeah, I think that's it, yeah.
Or what is God that man is made in his image?
That's another one.
Yeah, I know.
Yeah, that's another one. Okay, all right, so where are we? You wanna continue?
This is the same issue as the one which divided Gottfried Wilhelm Leibniz and Leonhard Euler. Leibniz had insisted that monads, or simple substances, are indestructible and indivisible. Euler, on the other hand, had incorrectly argued that all magnitude is divisible to infinity. To return to Nicolaus of Cusa's argument, if one recognizes the existence of incidental angles, the existence of incidental angles, and understands that an incidental angle is not proportional or commensurate with a rectilinear angle, then it is clear that there can be no rational proportion between the area of a circle and a rectilinearly enclosed area. As Cusanus writes, if a circle can be transformed into a square, then it necessarily follows that its segments can be transformed into rectilinearly enclosed figures. And since the latter is impossible, the former, from which it was deduced, must also be impossible. And then I can't read from that.
That will be the part when I give a class to prove that the opposite is true. That part right there.
Okay. Yeah.
No.
By demonstration.
Right at the edge of
It's
the
right
page.
at the edge,
The
Ernie.
fold of the paper.
So maybe you can find it on here where
Open up the paper.
more readable.
Obviously, then, the semicircle cannot be transformed into a rectilinearly enclosed figure, and consequently also not the circle or one of its parts. Similarly, Cusanus writes in respect to contingent or cornicular angles that
Page 4.
although they, sorry, you can just go ahead. Although they cannot be divided by another straight line,
Hold on a
No, maybe we don't.
there it is, under right above species difference on the
Yeah,
right hand side.
They are nonetheless. Yeah.
Sorry.
Yep. Similarly, Cusanus writes in respect to contingent or cornicular angles that, although they cannot be divided by another straight line, they are nonetheless divisible by another curved line.
Whoa.
The contingent angle is a divisible magnitude only in its species, since to every contingent angle there is a larger and a smaller contingent angle.
People see
Can you
that?
just read that last paragraph again?
Similarly,
Oh, that's interesting.
Cusanus writes in respect to contingent or cornicular angles that, although they cannot be divided by another straight line, they are nonetheless divisible by another curved line. The contingent angle is a divisible magnitude only in its species, since to every contingent angle there is a larger and a smaller contingent angle.
Okay. The people
Well,
see that.
You could imagine other
There must be a
other
picture.
curved lines lying between
A bigger
the
circle.
tangent and the circle.
Yeah.
Why don't you put that up so that people can see that, the cornicular angle? That would be, let me
Yeah,
see,
scroll
that's
to the
page-
percum.
That's page, that's on page 4.
Cut a particular angle in half with another connector.
Yeah, like if you
Yeah.
were to have a bigger circle,
Right.
then you would be able to, you know, put a line here.
Right.
Which you could never do a straight line, but you could do a curved line.
Right.
Or you could do one here.
And would it be based on how many times bigger that circle is than the original?
Well, that would be a relation, right?
You can just sneak another circle in here which has a less curvature, a larger diameter, and a less curvature, so it would go in here, see,
I
okay?
mean, that would look like the diagram from the Dr. Ignorantia on the infinite circle.
Yeah.
Going from larger to
Large, just a larger, it
Oh,
didn't have to be
yeah, yeah.
infinite,
Which
just
is
larger.
Eventually a straight line.
Yeah.
So do those two ideas have any relationship? What we're talking
No,
about
I think
here
it's
and
just
that-
straightforward. He's comparing two curves. He's saying that they're the same species. You can compare them. You can sneak a second one in there and then compare that one with the other one. That's the original circle. I don't think that's it.
AD would be an infinite circle.
Right.
Or it's hard to compare the angle between the curved and the straight. It's hard to compare.
Still, you can have, if they're both of that nature, you can compare them because they're the same species. Okay. All right. Well, let's see what Lynn has to say about all this, huh? Go to page 47.
Second page.
Oh, yeah.
Yeah.
There it is.
Okay.
What was this we were just reading?
Okay.
This thing here.
Very long.
Somebody want to read starting where it says in both cases?
I will. In both cases, Plato's Parmenides and Prusa's axiomatic revolutionary treatment of quadrature, we are presented with examples of a true metaphor in approximately the barest bones form of representation. Cusa's non-algebraic generation of the circle as constant change is the metaphor represented by Archimedean quadrature. That circle's existence cannot be competently defined in the axiomatic framework of ordinary Euclidean geometry. To construct a circle, we must employ a ruse of construction excluded from the underlying set of axioms and postulates of Euclidean theorem lattice. We must employ rotation, as one does by drawing the circle with a compass. Rotation is the ordering of action in non-algebraic space-time, not Euclidean space. This cannot be brushed aside with the argument that I am stretching a point here, or rotating a point here. There is a 450-year connected historical development from the origin of Cusa's discovery through Leonardo da Vinci, Kepler, Fermat, Huygens, Leibniz, Bernoulli, then to Hermite et al.
Who's that?
I don't know, at the close of the 19th century, to define rigorously the transcendental distinction of pi. It is often that proverbial smug hand-waving at the blackboard is employed to evade even the most devastatingly crucial issues. Such has been the long, stubborn refusal to acknowledge that rotation is axiomatically, ontologically external to a formal Euclidean theorem lattice, or as Augustine Cauchy's calculus has often been read to evade. The truth is that asymptotic lines are not theorems. Asymptotic limits are not theorems of the theorem lattice employed to describe the relevant function.
Yeah, okay, that's it. All right. Well, what do any people think of this? That's quite a statement. 450 years of Cusa? People, all of a sudden, Felix Klein is the one who pushed this thing, this idea that Hermite has finally discovered this idea that that pi is a transcendental number. It's it's an order of difference from the algebraic numbers, and also of the of the irrational numbers.
Who said that?
Yeah.
Klein?
So Felix Klein, who's like 1950s or 60s, something like that?
No,
When was
Felix
Felix
Klein was around, I don't know, 1850 to
Oh, really?
1920, something
Okay.
like that. He was a guy, Göttingen, who was supposedly presented himself as the guy who was protecting the classical tradition in mathematics,
Uh-huh.
Riemann and so on.
And he announced that Hermite, or whatever his name
Yeah,
was the
that's
guy
what
who
Lynn is getting
discovered
at.
Wait, he announced what?
that Hermite Day, or whatever his name
Hermite,
is.
yeah,
Hermite
Hermite.
was the guy who discovered that there was an ontological species difference between the circle and the straight line.
For pi.
Why does Lynn use the word roost? You see that he used the word roost
I
here?
saw that. And we're
Is
gonna
that
find it again.
the hand waving? Or is it?
It's in the second paragraph of
Creating the
the
circle.
column, 1, 2, 3, 4, 5 lines of the 5 or 6 lines.
Must employ a ruse.
We must employ rotation.
Oh, there we go.
He says, he said that circle's existence cannot be competently defined in the axiomatic framework of ordinary Euclidean geometry. Construct a circle, we must employ a ruse of construction excluded from the underlying set of axioms and postulates of Euclidean theorem space. So that's another question. Why does he say that the construction of the circle is excluded from those axioms and postulates?
Because there's no action in the Euclidean geometry.
Yeah, I think it.
Doesn't,
Yeah,
there's
I
no
think so.
physics involved,
Okay.
and rotation is a physical action.
Yeah, and also they're starting there with a point and a line, not.
Yeah, you start with an infinitesimal self-defined point in space, which is inherently non-physical because of what Phil was going through, right?
Yeah,
So
that's
if you
right.
start from the point and you build up, and then you build up to the circle by putting together as many little lines as you can, and then you've got a circle, which is the implication of Archimedes. Then you add up to a circle that's not transcendental. But then, if you the ruse that you have to employ is the human mind, because rotation is something that is an idea. I mean, it's, yeah.
Do
But
we
it-
know how Euclid
It's not
describes the circle?
I think he just plops it
How
down.
where it comes
He
from?
says start with.
Uh-huh.
I remember Lynn had this thing in the Science of Christian Economy. Khosrow Gandhi wrote him a letter, a query, and he said Khosrow sort of started with something particular, and Lynn said, if you tell me start with, I'll rip your argument apart. You know, and he would say you got to start with, you know, the axiomatics of the thing. So you can't just start with. Well, that's what that's
The assumption, like parallel lines.
Yeah. So
So he's saying rotation is primary and all the other things are created by rotation.
I would
That
think
the
so. And we had a national conference in 1983, 84, and the speech was called LaRouche Creates the World. And he started, you know, with the circle. He built up to the cone, and then the sections of the cone. It was, I don't know, I don't have a copy of it. It was he started the circle of action. He gets to these higher, you know, fire constructions that go on, you know, in the higher domain. But that was when we really started getting into certain new questions, new aspects. I mean, this whole thing that you're hearing, these ideas you'll be hearing, it's all see, some of it goes way back, you know, the 50s. Kuza, actually, he's telling you a lot about Kuza, but he didn't even know about Kuza. And when he arrived at his discovery, he didn't know about Kuza. You got to bear that in mind as we try to recreate how he made his discovery. He's doing this to help elucidate certain ideas, but this is not, strictly speaking, comparable ideas that he employed, but he's trying, it's a pedagogy, it's not exactly, you gotta bear that in mind. I think it's worth if you want to be historically specific about his discovery, you got to keep that in mind. That's all.
When would you say he became aware of Kutzen?
Well,
When he met
Helder made him
Helder.
aware of it.
Helder did.
When?
Through Helder.
When?
77?
77, 78.
Okay.
When he says non-algebraic spacetime, does that refer to non-constant change?
What do you think, Phil?
Non-algebraic space-time, it's negatively defined. I mean, I think he means a space-time that's not based on mechanical or linear or algebraic functions.
It's like if you go around a circle,
Yeah.
the value of the sine and cosine changes non-constantly.
Yeah.
Is
But
that what he's referring to or not?
No.
That's, well, the sine cosine functions are transcendental. But, you know, I think for our purposes to leave a little bit open as to where it all goes, these are just literally non-algebraic. In other words, algebraic means things that you can construct with a ruler and a compass. Okay, so even that is not quite a full transcendental.
Algebra would be limited to like integers and ratios, right?
Integers, ratios, exponents. One of the things it's also limited to, in a certain sense, is infinite functions. You know, an infinite something that gives you an infinite series, because then you're into a slightly different zone. But yeah, anything that's integers, basic plus and minus, you know, division and multiplication.
Would you say exponential powers?
Yeah.
Powers, x squared, so on.
Yeah, you can have exponentials. Yeah.
Powers. Yeah, in terms of I just came to mind, you know, the Lynn paper that he wrote on cold fusion for his 1992 campaign. This came up, I just thought of it because of this thing on Huygens I'm going to get through one of these days. Lynn talked about how physical space-time has a certain, he called it bubbly, it's everywhere dense with bubbles, spherical bubbles. So I think that has something to do with this idea of non-algebraic space-time. Now to finish up, we only have a few minutes, but for a little comic relief, I thought we'd look at John Wenck's attack on learned ignorance.
Oh, yeah.
Oh, wow.
Okay?
What's his name?
John Wank.
John Wank.
John
Probably
Wanker.
Wank.
Wank, I think.
The Wanker. John Wanker.
He's the guy who shows up at your table from time to time. Won't go away.
Okay.
He's infinitely extended.
Yeah.
You have a lot of guys come up and talk about learned ignorance.
Yeah, they're mostly ignorant.
I have a different
I'll learn.
position on learned ignorance.
People recall that.
Just sort
Yeah,
of
they
ignorant
generally come up
ignorance.
and talk about their wankers.
Yeah, right.
Anybody want to read it?
I'll read
Okay.
it. In Mark 1, we are commanded by the Savior to believe the gospel, for it is the indissoluble word of God. John 10, Scripture cannot be broken. In Galatians 1, the apostle gives scriptural teaching precedence over an angelic proclamation. Although we or an angel from heaven preach to you anything other than what we have preached to you, let him be accursed. I don't know what that means.
So if we contradict ourselves or somebody else, even an angel contradicts us, he'll be cursed? Is that what he's saying?
Okay.
Is this Wang speaking? This is
Yeah,
Dave?
this is
Okay,
this is
all right.
him, yeah.
Okay, all right.
Well, that's from Galatians.
Yeah.
Yeah, that's Paul, but.
Now, the gospel says in 1 Corinthians 13 that we understand through a mirror and in a symbolism. How then, in this life, would we incomprehensibly apprehend what is incomprehensible? For in this life, in which, according to Boethius, quote, everything which is received in accordance with the mode of the receiver, it is impossible for man to comprehend in any other way than comprehensively and in terms of an image. For as we learn from De Anima 3, the image is to the intellect that which color is to sight. Now, it is evident that without the objectively activating light of color, sight cannot see anything. Therefore, neither does it happen that we understand without an image. Accordingly, Holy Scripture has taught us through symbolisms that which is divinely inspired and revealed, also doing so conformably to the usual manner of our natural conception.
What do people think of his method of argument?
He's pulling quotes out from different people.
He's what?
He's pulling quotes out from different people.
Guess who?
Aristotle.
Aristotle's
Yeah, Lynn talks about the oligarchical enemy, and he says there's a red thread throughout for centuries. It's Aristotle. But what else? What else is he saying here? I mean, you know, this incomprehensibly, you know where that comes
You can't think of
from.
anything without a picture associated.
Yeah, what about that? What kind of a thought idea is that?
That's not true.
That's almost pagan, the idea. We're using the images.
What's the image for him?
It's the image for God.
Or gold or God.
Show me where it's written in the Constitution that you can.
And then, well, that last sentence there, accordingly, Holy Scripture has taught us through symbolisms that which is divinely inspired and revealed. So that's it. It's all in the book.
He's a fundy.
Yeah.
But it's interesting that with this point that Ernie makes about Aristotle, because he actually slips Aristotle in. You've got Galatians, you've got this, you've got Mark, you've got John, and then there's De Anima. I didn't know that was part of, is that the New Testament or the Old Testament?
You've got Galatians 1, Corinthians 13, and
De Anima 3.
It's funny because I hate to say that, but what's Laudato Si is written in a similar way.
It is there.
It's also the thing with symbolism. What about metaphor?
Right.
He's outlawing metaphor.
Yeah.
So anyway, you know, you'll see Kuza wrote a reply,
130.
and one of the things he said is, "Cast not your pearls before swine."
Is that where that expression came from?
No.
Nah.
Oh, it was.
No, that's in the Bible.
That's
That's in the
funny.
Bible.
You want to read the next paragraph, see what else he's got to say.
But in order to escape all calling into question of his arguments, this author of learned ignorance resorts to the following stratagem. Namely, he asserts that in incomprehensibly embracing such deep and incomprehensible matters, the whole effort of our human intelligence elevates itself unto that simplicity where contradictories coincide. And he says that the conception of his first book labors with this task. He calls this simplicity God, not understanding that which the verse stated, namely that I am God, with whom no created thing coincides, and with whom nothing from the nature of anything is mingled. Now, if the aforesaid teacher of learned ignorance wants in this way to prevent all opposition, then there will be no contradiction there. And who will refute him, since in that case no inference could be established? For there would be no inconsistency between an antecedent and a consequent opposite to it. What then would become of the inferences of our Savior's prophets, evangelists, and apostles, by which our faith is seen to be in no small measure confirmed against the infidels? Moreover, such teaching as this author's destroys the fundamental principle of all knowledge, namely the principles that it is impossible both to be and not to be the same thing, as we read in metaphysics.
There we go.
But this man cares little for the sayings of Aristotle.
Truth. There's an insight.
For he says that he always sets out from one and the same foundation.
Next page.
And that he has elicited beyond the usual approach of the philosophers teachings which will seem unusual to many. Wherefore, allegedly, the Lord Jesus has been magnified in his understanding and affection through an increase of his faith. Now, he says that his own foundation is the following principle, namely, that with regard to the most simple and most abstract understanding, all things are one. Wherefore, it is necessary that there all things lose all differentiation. I have collected into theses and corollaries, because of the better possibility of their being remembered, the points elicited by him on the basis of this foundation. I will deal with them in sequence in what follows, but beforehand I will explain why I attached the title Unknown Learning to this writing.
Well, I think that's, we get the gist of it. Okay, Daniel, you want to say anything about, in terms of what he's saying about Kuza, you know, actually? I think he's completely misrepresenting a lot of stuff. But then that's the idea. He's of a different species altogether. I think that's.
Hey, it's the pearls before swine. I think that was the right answer.
From the time of the Council of Trent, Nicholas Kuza was essentially outlawed in the Catholic Church.
When was the council?
1525.
Uh-huh. When?
1525.
Uh-huh.
Wow.
Like 1900. It was not really until we started talking about it that it actually was brought back in as an active intellectual pursuit in the Catholic Church.
Mhm.
John Paul II and Ratzinger, partially because he was determined to be a mystic. And that's the way the Kuza was dismissed.
Uh-huh. Mathematical mystic also, I guess.
Yeah, well, that also, but in terms of the church, in terms
Yeah.
of the doctrine, he was a mystic.
Uh-huh.
And it took John Paul II to essentially rehabilitate him. So the reason is because that's what he just said, is that there's no way to actually comprehend what Cruz is saying, because it's all, unless you do it through a Thomas Aquinas filter, it's not seen as clear argument. You haven't presented the clear argument as to why, how the theology is supposed to work. That's why he's doing the thing with corollaries and so on. That's why he's doing that.
So you're saying he's trying to sort of imitate Aquinas's sort of.
Well, what they do is not Aquinas, but he's trying to use Aristotle's method to argue under the guise of doing it like Aquinas.
Okay.
He's now going to try to tell you in a serious way, by categorization, what Kuza wasn't willing to admit he didn't know. That's what's going on there.
Okay.
Can someone get I can't plug this into my phone and the case is too hard to get off. Someone want to get that late afternoon update?
He reminds me also of Bertrand Russell, because in that the idea, he uses directly the idea that Kuza says I'm doing something completely different and new as a way of discrediting Kuza. That anyone who says that I've made a discovery of something completely new must be crazy.
Well, I think it is fair to say that much of the scholastic world the idea was deductive, but that's not just to repeat one's word. That the idea was you had the truth in some combination of scripture and Aristotle as being the accepted authority, and everything was to be deduced from that. So it is very much the same kind of outlook. It's all there.
Creatives.
Yeah.